Have you ever looked at a massive cargo ship and wondered why the bottom is almost completely flat? Not pointed like a yacht, not deeply curved, just a huge flat surface sitting low in the water. How did this idea even start? What did ships look like before this design became normal? What problems made the old shapes fail for giant vessels? Who figured out the better way? And what hidden reasons keep this flat bottom on nearly every big freighter today? Welcome to Story Behind the Things. For most of history, ships were built with rounded or V-shaped bottoms. Think of old sailing ships, clippers, even many early steam vessels. They had deep keels. The weight sat low, that heavy keel acted like a pendulum. When waves tried to tip the ship, the low weight pulled it back upright. That system is called weight stability. It worked well for smaller ships that needed to handle rough, open ocean, but it came with serious limits. The deeper the keel, the deeper the draft. Draft is how far the ship sits below the waterline. A deep draft ship needs deep water. Many ports and rivers simply could not handle them. Cargo space was also limited. The curved shape wasted volume that could have held more goods. As global trade exploded in the late 1800s and early 1900s, ship owners wanted bigger loads and access to more harbors. The old deep-keeled designs started holding them back. Naval architects began looking for a different kind of stability. They found it in form stability. Instead of relying only on heavy weight low down, they made the hull very wide and relatively flat. When a wide, flat-bottomed ship tilts even a little, the center of buoyancy shifts hard to the side. That creates a strong righting force that pushes the ship back level. The wider the beam, the stronger the effect. Suddenly, you did not need an extremely deep, heavy keel. The shape itself kept the vessel upright. This change solved the draft problem. A flat bottom spreads the ship's weight over a much larger area. The vessel sits higher in the water for the same total displacement. Shallow draft means it can enter ports that would ground a deep V ship. That single advantage opened thousands of harbors around the world to the largest freighters. At the same time, the boxy shape created enormous internal volume. Containers stack neatly. Bulk cargo fills every corner. The ship becomes a floating warehouse instead of a tapered tube. There is another clever part most people never notice. When a cargo ship unloads, it becomes top-heavy and less stable. In the old days, sailors filled the bottom with rocks or iron as ballast. Today, flat-bottom ships pump millions of gallons of seawater into tanks built right into that flat floor. The added weight lowers the center of gravity again. When the ship loads cargo, the ballast water is pumped out. The system is simple, efficient, and only practical because the bottom is flat and wide enough for those huge tanks. Modern designs push the idea even further. Some ships release tiny air bubbles under the flat hull. The bubbles reduce friction with the water and save fuel. Double bottoms add an extra layer of safety in case of grounding. Stabilizers and advanced weather routing help the flat hull handle rough seas better than early critics expected. The design is not perfect for every condition. Yachts and warships still prefer deeper or more curved shapes for speed and seakeeping. But for massive commercial ships, the priorities are different. Carry more, reach more ports, stay stable enough, make money. So the next time you see a giant container ship or bulk carrier, remember the long path that led to its flat bottom. From deep-keeled sailing vessels limited by draft and cargo space, through the rise of global trade that demanded bigger and more flexible ships, to the quiet science of form stability and ballast water that made the flat design possible. It was never just about looking simple, it was about solving real limits of size, ports, and profit. And that's the surprising story behind the flat bottoms of massive ships. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the story behind the things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.